okay, in your requirement document. There's nothing wrong with that. Okay, this is just more detailed step by step. Okay?
Okay, so the scenario.
So you could put all the scenario
go
here.
in one or the other.
One or another, other. But so you can, but one thing that you shouldn't be doing is just put this diagram in your requirement document and say, oh, that's my requirement document. This is not sufficient information. You still need to have, for each one of them, a step by step. Okay? The step by step is a summary of all the scenarios, essentially. Scenario is basically breaking down into different branches in your use case. That's it. Don't make it too complicated. Scenario is just making a branching clear.
Okay.
So you can say my functionality is, this is my function. It's doing this, this, and this. You can also say, okay, guess what? It's in the middle. It's actually happening like this, right? If you enumerate like this scenario, if you talk about the whole thing, use case. Okay. I mean, this is a good question. There could be some confusion about. I mean, actually, in some cases, scenario is that use case. There's actually no branching, no exception, which is uncommon, right? Even if you register a user, you could have exception scenarios, right? Scenario is more common, but it could be the case you have no scenario, just one single use case. All right. So this is use case. This is use case diagram, and step by step for each use case. That's what I'm looking for in your requirement document. Okay? In your design document, I'm actually looking for your class diagram with attribute associated, and eventually, as we go, this is just repeat the use case assignment, realization. The rest is just giving you more and more examples. They don't show that because it's probably too big. Okay. Eventually, what I'm looking for in your design phase, we'll talk about in the classes, the class diagrams. Could be like this. Could be like this. What I'm looking for is your class, attributes, and methods, and how you get to them. How you get to them.
Is that different than UML? Is that different than UML?
That's definitely different from UML. But UML is just one representation, okay? So your design approach has nothing to do with UML, okay? UML is just a way to representing your design, okay? It's not your design approach. Your design approach is actually take use case, refine it into scenarios, basically going to cover all the branches, right? When you talk about use case, it's a big, I'm going to do this functionality, right? However, that is typically not totally directly implementable. That's why you want to implement, you want to refine it into consider all the branches. Now it's implementable, right? Then this is your step. Then you assign each functionality to a class. Has to be, right? If it's not, there's no bearer of this action, then this action is not necessary, or you're wrong. Either way, no exception, right? If it need to be here, nobody implementing this, your design is wrong. If it doesn't need to be here, then you don't have to have this to begin with, right? So essentially, what we'll be looking for is the classes, the attributes, and actions. All together, they should be able to implement all the scenarios. So you can see that the core thing here is you are going from English spec to use case diagram, then going to scenarios. Actually, each scenario is represented by, eventually by, this collaboration diagram. This is actually a scenario. Each scenario corresponding to one collaboration diagram. This is how you, so this is coverage, okay? You can see that coverage is important. Why is coverage important? Because if you can have overlapping coverage, which just means that your design is inefficient or unnecessary. But if you have gaps, then your design is actually incorrect. Okay? If I put all these collaboration diagrams together, I covered all the functionality you can enumerate or even think about in the original specification. You got a design. If you have a part of that diagram, a part of that specification, not ever covered by any scenario, you have a wrong design. If you have overlap coverage like this, you have a poor design. But you have a design. Okay? That is definitely qualified for partial credit. Because you can implement that, just not efficient, and you are wasting a lot of your time implementing duplicated things, right? Can I say that? Could I say that's a wrong design? I couldn't say that's a wrong design because you got the job done. Just that you may not have the best design, the efficiency may be bad, or you spend more time implementing it, right? But if you have gaps like this, which really means that, hey, you didn't get your job done. That's the wrong design. Okay? So how do we tell it's a correct design or incorrect design? Easy. We basically look at it and see, have you enumerate all the possible scenarios in the original description? If yes, you got a pass. If not, I got you. In this case, you missed it. Right? That is essentially, in the end, this is how we decide whether a design would work or not. Questions? Okay? This is, conceptually pretty straightforward. So from English spec to use cases, right? Then you do your non-extraction or verb identification to get you your class diagram, your scenarios. The end goal, okay, is actually to have all your classes listed, attribute assigned, method assigned. Then your high-level design is completed. Okay? That's your job. If you think you can do that job, you can actually find a real job. Literally. Because you are asked to do exactly that. When we talk about detailed design, we're really going into, should I pick a linked list? Should I pick a stack? Should I use a Huffman encoding? Should I do this? Okay? But that is when we are actually working within that object itself. Flush out the details. What should be the data format? Should we use an array to hold the information, or should we use a linked list to hold that information? Okay? That is our detailed design. Implementation is really you go, just like the next 20 minutes, you go, you sit there and write out that damn code for that trade. Oh, I'm going to do a trade today. I just leaked a little bit of information today, right? That's it. That's our work. In an unglorified fashion, that's your life for next probably 10 years, 20 years, 30 years, 35 years in software engineering. It's not going to be like that, totally, but that's the base, okay? You are going to basically take specification, convert that into running code. How? Use case, identify classes you want to implement, assign attributes, assign methods, deciding algorithm, writing code, get it tested, integrated, run. If you cover all the functionality in the original spec, or the change spec your user provide you, you're golden. If not, the users are going to be yelling at you and ask you to change it. All right, that is essentially fundamental software engineering process, and the skill set you're learning here are the basics. This is not making you the best basketball player. This is making you know how to dribble and how to play basketball. Are you going to be the best basketball player? Who knows, right? But are you going to be a basketball player, go out at some court and start playing? Yeah, you could. Just like you, the same as, are you the best software engineer, or you are a software engineer starting doing things? Same idea. Well, now we're really talking about fundamentals, right? Rules of basketball, how to dribble, how to shoot, and that's it, right? I mean, if you go play with those NBA players, it's hopeless. Just like we go challenge them other top software engineer in terms of design, it's probably hopeless at this point. But after enough practice, you may get there. Okay? But fundamentally, from spec to use case, from use case to object, to classes you identified, assign the attribute, assign the action, deciding on the algorithm, write out the code, test, submit. That's our term. That's how we work. My job basically here is to make sure you got that basic training. You show that by implementing the project on your own, and also being able to show that you can work independently in my test. Because when you go home, you can have your girlfriend, your boyfriend do the job for you, so I cannot check, right? So I will eventually have you back in the classroom with no help, show that you're capable of doing that job. Then my job is done. You can move on to the next class and learn more optimized way of doing all the software systems. That's not my job anymore. My job is for you to demonstrate you have the proficiency of work out a non-trivial system from ground up, all the way from English spec to running code in Java and deliver on the functionality. Provide 100% coverage to the functionality we want you to implement in the original spec. That is the requirement of CS300. Questions? Okay? So far we have talked about requirement, we have talked about high-level design. Just one more recap. In the requirement, we are trying really hard to get to use case diagram. We look at system from outside, identify who are the users, what is the system, what functionality the system should have. Then we run you can also identify what are the behaviors from in terms of dynamic point of view. Then we run our maybe most trivial non-extraction, right? Non-extraction to actually get the classes. Then we use our use case to refine it into scenarios so we can assign blames to all the classes. Somebody needs to take the blame, right? Otherwise, who will take the responsibility, right? Somebody needs to get that responsibility. If you get responsibility, which means you come to here. Okay? For each scenario, there is an implementation of that scenario in terms of collaboration diagram. For all the scenarios, this is what I'm looking for in your design document. Your design document should have class diagram, right? Scenarios, refine it into collaboration diagram. Then I'm clear you cover them all. This is about coverage. This is actually about coverage. If we cover them all, then next time we'll talk about what is going to be the design, not in a detailed design, but that's more data format, algorithm picking, that kind of thing, data structure picking, right? Those are things that you already have some idea. Once you get the implementation, you're on your own. You have learned before to how to implement one single class a time. One single class a time. So essentially you can see we are bridging the gap between a system and a class. A class you know how to implement. I mean, every time I give a quiz, you guys are writing the class. I see no problem. My job is to bridge the system and the class implementation. If I can bridge that, you actually can use your skill to attack real system. That's our class. Make sense? If you don't ask question, I'm just going to assume that you understand what I'm looking for. Okay? You can blame me for not making it clear what we are looking for in the requirement document, in the design document. Right? All right. Okay. If no questions, we'll go into our quiz today. As I mentioned already, our quiz is going to be a tray. This is a binary tray. You should not be using the library tray, right? You should create this binary tray by yourself. So this is exactly the level you should be at right now. So that's my interface with column and other instructors below 300, right? I'm assuming you have the capability of writing a class out by yourself. In terms of defining the interface of the class, the attributes of the class, internal attribute, private data member of the class, the interface of the class, then implement the data structure, right? So our class is to how you augment that skill with a class hierarchy, so you scale out to a reasonable and modest-sized system. Okay, that's our setup. Binary tray is straightforward, right? So we have something called the root, which can point to something called nothing. That's a possibility. Or it's going to point to an element, right? So this is the entry of the root. Then this element can have two children of their own. Either can be a nail or can be another node. Then this can repeat forever. Certainly not forever because we don't have unlimited storage space, right? So we eventually these guys will run out of child. They just will be the leaf node themselves, right? So you are asked to basically maintain this data structure. One of the most useful data structure in whole computer science. The first ever search is done on this tree, right? More optimized search. Binary search is much more efficient than you search a linked list. Binary search is log n, right? So much faster than your linked list and ON search, which basically linear. When it's logarithmic, clearly logarithmic is more efficient. And next time I'll ask you to add more functionality to this tree by adding additional algorithm. I